Okay, first thing I want to talk about is domain and range. On your notes, I'd like you to write domain. And I'd like you to write range. I know I already asked you to memorize that domain is like the X stuff and range is like the Y stuff. Hopefully you had that in your back of your mind. But when you actually look at a graph, let's say this one. This is the square root function. Why does it look that way? Because if you look at y equals the square root of x, if I put in 0 for x, I get 0 out for y. It's a little combination of x and y. If x is 0, y would be 0. So I put a dot right there. If I put in 1 for x, do you get that the square root of 1 would be 1? So 1, 1 is on there. And then if I go to 4, because it's a nice number, square root of 4 would be 2. So I go over 4 and up 2. You get the idea of how that square root thing works? Yes? No. Square root of... Okay, so 25, if I put 25 here, then it would be 5. You're right. But I have to go way over to 25, which would be way off the screen, and then go up 5. So, do you get that this thing keeps going up, though? It goes up slowly, but it just keeps going up, 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 up. It's really slowly. Okay, if I discontinue it, it's going to keep going up, but it's just a really slow rise. Okay, so here's the question. What's the domain of the green function? Well, domain means x, right? So what are the numbers that would work for it? Do you get that I cannot use numbers over here? Why not? Yes. Yeah, this would be like -2 over here. And if I was going to check that spot, -2, I can't put a square root of -2. Can't do it. Doesn't exist. Not in the real world. Okay? So that means that this thing doesn't start working until what for x? 0. 0 does work, because the square root of 0 is okay. What's the square root of 0? 0, because 0 times 0 is 0. All right, so 0 to, what's the biggest number that you'd have for this function? Like, as if we're talking about x's, it's how far this way, which the smallest one was 0, but how far would it go that way? Keeps working all the way to infinity. Very good. 0 to infinity. And then the next thing is we need to learn what's called interval form. He's actually learning a lot of stuff right now if you were paying attention. All right. It goes from 0 to infinity. You need brackets and parentheses. The brackets that you need are for things that work. Does 0 actually work in this function? Yes. Can you actually use infinity? Is it a place you're going to get to? No. So you have a parenthesis around that. Okay, if you are taking notes, that would be very smart right now. If you're doing anything else, stop that and get back to me. All right, range of this thing. The range is how... So for domain, domain is like this. How far left, how far right? What do you think range is like? How far down, how far up? So on the range here, what's the lowest it'll ever go? This green function, the lowest it ever goes this way, 0. 2, what's the highest it'll ever go this way? Yes, the square root of infinity, which is also infinity. All right, so infinity. So then, the brackets and the parentheses, can it actually be 0? Yes. Can it actually be infinity? All right. There's the domain and range of that function. All right, I'm going to give you another one, and this will really tell me whether or not you understand this. I'm going to give you a half circle. A full circle is not a function. Can anybody tell me why? Yes. You got it. Does not pass the vertical line test. Because if I take a spot like here, it has 2 outputs, there, and that's not allowed. A function. All right, so I can do a half circle, though, for a function. That is a function. Okay, that's a function. All right, and if it's really a circle, then the distance here, here, and here is all the same, right? What are those called? The radius. So let's say that the radius is 3. So this spot right there is a 3. And that spot over there would, of course, be a -3. Would you tell me, sketch this just real quick, and then tell me the domain and the range, D and R. If you really understand what I just told you, You should be able to tell me the domain and range of this function. Don't just sit there, put your hands in your pocket. If nothing else, you can copy down my picture and you can write down the words. All right, domain means this way to this way. Lowest to the highest. So, what's the lowest it ever goes? This way. -3. To the highest it ever goes, that way. 3. Brackets or parentheses? Brackets. Because it gets to them. You touch 3 with a circle. How about the range? The range is this way to this way. Lowest to the highest. What's the lowest it ever goes? Be careful now. 0. Yes. A lot of people say -3 because they get confused, but it doesn't go any lower than that. It gets to 0 and it stops. How's the highest it ever goes? Very good. You knew that because this is a radius of a circle. It has to be the same as this. So 3, and then that's a bracket here and a bracket here. All brackets on this one. Raise your hand if you had that one right. Good. And you bit the basics of domain and range. All right, one more kind. Let's say I had the old-fashioned parabola. It looks like this. You've done it before. How do you know exactly where it goes? X, Y. You make a little list, and you say, okay, if I stick in 0 for X, I'd have 0 for Y. 1, and if this is squared, the whole point is it's X squared. 1 squared is 1. 2 squared would be 4. 3 squared would be 9, etc. All right, so this one, what's its domain and what's its range? Just don't even write them. Just think them with me. What's the domain? Say it if you know it. Domain is this way. It's not positive infinity. It's negative infinity. The other way for domain? Positive infinity. Then for range, what's the lowest it ever goes? 0. To the highest it ever goes? Infinity. Okay? That's what domain and range mean. You're going to use those a lot this year. Again, it's on your next quiz. And it's also in next year a lot in pre-calc. You use domain and range a ton. We get to much more complicated domains and ranges. And then when you go to calc, if you decide to go there, domain becomes really, really important. So this is just the beginning of it. Yes? I'll do them specifically. Domain here, since they're negative to infinity to positive infinity, you can never get to those. And then since the range, you can actually be at 0 on this function. And it goes to positive infinity, which has parentheses. Right? All right. Next concept, absolute value. Did I briefly show you this before, or have you never seen the V shape before? It's not a U, it's a V. Told you yesterday? Okay. Then just real quick, do you get how this domain would be from negative infinity to positive infinity again? And then do you get how it's the same thing as a parabola on the range? 0 to infinity, because these keep going up. All right, moving on. Generally speaking, the x squared is a U shape. The square root function is this, it kind of looks like a ramp. I don't know. I have a hard time explaining what that looks like. My best example, I think, for the square root is that it looks like a parabola buried in the sand, because it follows the same pattern as a parabola. It's just that it's on its side. You got to kind of turn your head sideways and you can see it's a parabola. Okay? And the rest of the parabola would be over here, but that part's buried in the sand. Okay, so that's the square root function. And the other one is the absolute value, and that makes a V shape. All right, now the next part is really important, and that's about moving them around. If I have y equals x squared and it looks like this, if I want to move it over here to the right, what do I do to it? Well, if you put stuff in a parentheses right next to the x, then that's going to make it move to the right or the left. So this right here, I hope you know if we're talking right or left, your gut feeling should tell you that the negative numbers are over here, so if I should probably move it to the left. But it's the exact opposite of that. Because everything that's inside the parentheses is counterintuitive. Intuitive means that you understand it easily. It makes sense to you. Like if I say up, that means positive, and down would mean negative. Do you get that that's logical? Intuitive? Okay, well, everything on inside these parentheses always goes the opposite way you would think. If you times it by 2, it seems like it should get twice as big. It actually gets half as big. Everything you do in the parentheses does the opposite of what you'd think. All right, so if I said, let's look at this one here. If I say, I've told you before, the stuff in here is left and right. And doesn't it seem like it should be left 4? Because that's where the negatives are. So you do the opposite of that. This one right here would go to the right 4. So my parabola, that normally would be like here. That's really annoying with those pipes, isn't it? Oh. Okay, anyway. Now if I take this U shape and I move him over 4 spots to the right, it's going to be over there. Okay? And it should be the opposite of what you'd expect. You'd expect it to go 4 to the left, like over here, but it actually goes to the right. Now I want you to not just believe me on that. I want to actually do one with you. So grab your graphing calculator quick. If you don't have one, hurry up and borrow one of mine. You should have one by now, but make it, just get it as soon as you can. So now, I want you to just graph this one we just did. X minus 4 quantity squared. Just use a parentheses. And I think you'll see that the whole thing moves to the right 4 spots. So you're going to go to the y equals screen. If it was plus 4, it would move to the left. So it's x minus 4 in parentheses squared. So I'm going to go here, do that, bring this over so people at home can see it. X, oh, wait, I need parentheses. Parentheses, x minus 4, parentheses, and I hit graph. I just forgot the square. Sorry, x minus 4 squared. Come on. Squared. Now I graph. There we go. Do you see how it moved to the right? All right. Everything inside is counterintuitive. All right. The stuff on the outside, though, that does what you'd expect. Let me ask you. If I just had a parabola like this, and I put a minus 5 over here, do you get how that's not in the parentheses?
Yeah.
And therefore, it's not a left-right thing, so therefore, what would you expect? It's not a left-right thing. The things in the parentheses are left and right. What do you think that is then? That is up and down. Stuff in here is left and right. Stuff on the outside is up and down. Okay, and then, if it's up or down, wouldn't negative sort of make you think it's going to go down? And you can trust the stuff that's on the outside. It is intuitive on the outside. All right, so to sum it up for you, if I had this, let's go with parentheses. Do you get it's moved left, right, and it's moved up, down? Do you get that the stuff on the inside you can't trust? Stuff on the outside you can? Doesn't this, if it's left, right, which one is it? Is it left or is it right? Seems like it's going to be left, but it's actually right. Good. So it's right, 3. And this one right here, it's not left, right, it's up, down. So does it seem like it should be up or down? It seems like it should be up, and therefore it is up. Because the stuff on the outside you can trust. Got a good story. A friend of mine was in prison, did a bad thing, took responsibility, actually admitted it, pled guilty, got prison time, and then he was in prison for a while and had some pretty crazy experiences. One of which was they threw him, a new guy, into his cell one night, Your roommate's called your cellie, by the way, in case you don't know prison lingo, which I hope you won't. So his cellie was this new guy that just got thrown in, and they had picked him up for driving a stolen car. But what he told him that night was he had actually just killed 2 people and then stole their car. And the cops didn't know that yet. All they knew is he stole a car. And the cops were eventually going to figure it out, and he knew that. And he was stuck in prison, and he was just freaking out because he knew that as soon as they were, he's already killed 2 people now, and now he's in the cell with you. Can you imagine that? And yeah, my friend didn't kill the people. My friend, he made a different mistake. But anyway, he was like a low-level criminal compared to this. And so this guy that had just killed 2 people and got picked up in a stolen car, he told him all of this at night. He was like, just wanted to tell somebody, and so he wanted to talk, so he talked about it. I think that's a human reaction to just want to talk about things like big, scary events that happen to you. So then the guy realized in the morning, wait a minute, this guy is the only person in the world he's told is me. So he's the only witness that could be called in to testify in court that he had done this. And not only is he the only guy who knows about it, but he's the one who, if this guy gets convicted of killing these other 2 people, it was in a state that allows the death penalty. So the guy who's now been thrown into the cell with my friend knows that he's probably going to get the death penalty if he gets caught for this other murder. And so he starts thinking, even though it's flawed thinking, he starts thinking, well, if I can just stay here in Wisconsin and get punished for something in Wisconsin, then they won't be able to get me for the death penalty from Illinois or wherever he did the murders. So he thinks, what could I do in Wisconsin that's really bad so that they can keep me in Wisconsin where there is no death penalty and keep me in jail here, because I don't want to go back to, what if I kill the guy I'm in the cell with? Then I won't have to go back, and he's the only one who knows about the other. So anyway, yeah, it was a very good chance that my friend would have got killed that night in that cell. And that happens all the time. Prisoners kill each other. And that's one of the reasons they don't like to put violent people in with not violent people, because basically the violent people will do violent things to the other people. So anyway, he was lucky to survive that one. They shouldn't have ever put him in there, but they didn't know he was a murderer either when the police threw him in the cell. Moral of the story, the guy did get busted for that other murder, and he was wrong about the whole, like, if you commit another murder, it can, like, keep you in that state. There's still extradition with all the states of the United States. They're going to extradite to the other state. So basically, if he killed somebody else in Wisconsin, it wouldn't have helped. He would have to get back. Why am I telling you all this? Just because it's kind of an interesting true story about the inside. And so never trust stuff on the inside. Brings it all back to math. So the stuff in there, seems like I should be moving left 3. Actually, move right 3. Don't trust the stuff on the inside. All right. So let's see if you really get this. It would be hard to sleep, wouldn't it? Knowing that if you fall asleep, they could like sneak down and attack you in the night. All right, this one. Tell me, what shape is it? Very good, V shape. Where has it been moved? Left, right? This is left, right. This is up, down. One thing at a time. What does that do to it? It seems like it should be to the right, but you can't trust what's on the inside. So it'd be left, 5. This one, do you agree? It seems like it should move down. And it does, because you can trust the stuff on the outside. Good question. What if the murderer gets out of the prison? Then can you still trust him because he's on the outside? Okay. I like that. At least you stretched the analogy so far. It's finally broken. All right. So now, I told you that the stuff on the inside, like if you did anything on the inside, it's the opposite of what you think. So if I put 5x, do you get it? Seems like it should be 5 times bigger, but it's actually 5 times smaller because it's the opposite of what you think. All right. And this, if I put the 5 on the outside, it seems like it should get 5 times taller, and it does get 5 times taller on the outside. All right. Yes, it's okay. It's recorded. Guy's already in prison. They've caught him. They know he did those. They did those murders. And yes, there is a death penalty. But for example, there's a guy on death row that's currently been on death row for 30 years. And he is petitioning the court that he should not be executed because he is too fat.
I don't get it.
He's 480 pounds.
What is that?
And, well, because it's the state's fault that he's so fat because they've been the one feeding him this whole time. Nope. He went into prison not nearly so fat. But then bottom line is if you can just, fatten yourself up enough, you can get out of being executed. That's what he's appealing. But the last person who tried to do this, actually that's part of it. They think that he might not be able to fit on the gurney that they bring him in on. And then he's saying that his arms are, he's got so much fat that you won't even be able to get in the vein when you try to, it's lethal injection. It's not, I don't think there's any states that do electrocution anymore. It's almost all lethal injection. And so anyway, that's what his argument is. But they say that the state won't, that it's very unlikely that they'll accept that argument. But that's his argument. All right, moving on. If your homework looks like this, and it asks you to find, it's called an investigation, but it's the only assignment listed on Schoology. Everybody go to Schoology, see if you can find the assignment. Under Schoology, look for today's date, which if you don't know it, you can always exit out of your iPad and come back into it, and it'll remind you quick what the date is. But it's the 20th. So you're looking for 9/20, and it says translations. By the way, a translation just means a move. You're moving up, right, left, or up, down, left, or right. So do you get that this one is just your classic parabola? Y equals x squared. This one is your classic parabola, except slightly different. It's not a parent anymore. It's a child function. It's a little bit changed from the original. Just like you are a little bit changed from your parents, you look a little different. Sometimes I've seen families where they just all look alike, and it's pretty amazing. Family resemblance. And some other families where you really couldn't even tell if the kids were, from those parents. But you usually carry over some traits. Well, anyway, this one's been moved which way? The common mistake is to say right 2, and it's instead down 2. So then this thing should be moved down 2. So I'm going to go down 2 right there, my first dot, and then I go over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, and then I can go over 1, 2, 3, and up 1, 2, 4, 5, 6, 7, 8, 9. And this, if I were you, I'd be using the zoom feature on your Remarks app. Because if you zoom in with the little thing in the bottom, it looks like a magnifying glass. It works, it's much easier to get those dots in the right place. You need to learn how to use that zoom thing. You're on the right spot. Just keep that zoom thing. And that brings you into a super zoom into that area. And then you can move that area around by using this little thing. Or you can.
Right here.
Yep, so now, see, now it's zooming in on that area. Just play with it. You'll get used to where it's zooming in. Okay? Yes. In the last 10 minutes of classics. All right, so just, guys, I'm in the middle of teaching. I'm not going to stop teaching to do the news show. And if our news show worked at the beginning of the hour, I'd show it then, but I can't. So we'll just have to deal with it. I'll get to it when I'll get to it. I'm almost done here. All right, so we'll move on to the next problem where it says, let's see here. Drag this up. Oh, so much junk on the screen. Having technical issues. There we go. Drag that up. Move this over. And delete that. And now I can take and move my parabola plus 2, which means up 2. Basically, I would use your zoom feature and move the whole thing up 2. So here's my normal parabola would be like this kind of thing. So I'm going to take those dots and move them all up 2 from where they used to be, which is about like that. All right, so I hope you know what this function is. That's a square root one. It generally kind of looks like that. And then I have to move the whole thing to the right 3. Okay, I think you got enough now where you can handle it on your own.